Introduction. Have you ever wondered who came up with math? Well, the answer to that question is easy. No one came up with math. Math has existed in one form or another ever since mankind evolved from the apes, and probably even earlier than that. Naturally, at that time they didn't calculate the percentage increase in plants from one year to the next. It was extremely simple mathematics, such as seeing that 3 bananas are more than 1 banana. During the first 100 or 200,000 years, mathematics didn't evolve very quickly. The first mathematical object found is a bone from a baboon that somebody had carved 29 notches in. It's thought to be approximately 35,000 years old. It is suggested that this bone was cut in an attempt to measure time, but we can't know for sure. I mean, no one was there and wrote it down, right? There was also carvings from the ancient Egypt, even earlier than the ancient Egypt you probably think about. These are from 5000 BC, and they look like geometrical designs. But that is not very interesting, now is it? No, the interesting stuff starts happening in the ancient country of Mesopotamia, which lies where Iraq is today. But what was so special about the Mesopotamian mathematics? Let's hear.
Babylonian mathematics. Babylonian mathematics is the name for all the mathematics that the people of Mesopotamia came up with. In that days, they needed the mathematics to create a calendar, for example, to see a pattern for when the rivers overflow. We can find signs of Babylonian mathematics from year 3000 BC. From year 2500 BC, we found signs of the multiplication table and division that the people in Iraq used. They were called the Sumerians. But how have we found signs of mathematics from that time? Well, they recorded everything on clay tablets, so all their calculations can be found there. But of course they didn't use the same number system as we use today, because the numbers has developed through history. They used a sexagesimal number system, which meant that they had 60 as a base. A mistake that the people of Mesopotamia did, without thinking of, was that they actually used the mathematical methods, such as Pythagoras' theorem, that was established in Greece, before they were established. They also used algebra, which was established during the spreading of the Islamic mathematics by Muhammad al-Khwarizmi. So basically, the great theories of mathematics have been used before they were established by the great mathematicians. One of the most antique mathematical texts is Plintham 322, which basically is a clay tablet that was written in between 80,022 to 17,084 BC in southern Iraq. The table had the Pythagorean triple engraved. A theory to why the mathematic method was not established in Mesopotamia but in Greece was because they think that the clay tablet was written by a teacher, so we could use it as an example for the students. Another part of the mathematics that they established was the square root. The archaeologists have found clay tablets with squares of numbers up to 59. They also used algebra, and clay tablets with multiplication, division, and equations have been found from the Babylonian time. They also found out that a circle has 360 degrees. This is life-changing because it has allowed us to learn how to calculate the volume of a sphere, for example. The people of Mesopotamia also knew the rules of geometry. They knew how to calculate volume and area. They calculated, for example, the volume of a cylinder that we still use today. They also calculated the perimeter and area of a circle, but they did it different than we do today. To calculate the perimeter, they took the diameter to the power of 3, and the area was calculated by taking 1/12 of the perimeter squared. This is actually wrong, because pi is approximately 3.14, but if pi would be 3, their calculations would be correct. And except for all the methods that the people of Mesopotamia used that are very helpful for us, and that we still use today, there is something that the people of Mesopotamia came up with, and that is life-changing for us nowadays in 2012, and it is the time. Like I mentioned in the beginning, the people of Mesopotamia didn't use the same number system as we use today. They used a number system that is with a base of 60, and nowadays we're using a number system with a base of 10. So, thanks to the Babylonian people, we have 60 seconds in a minute and 60 minutes in an hour. This is quite fascinating.
Medieval mathematics. During the 4th to 12th century, Europe had fallen into the Dark Ages, in which science and mathematics were very unpopular. The people in schools only valued studies in the humanities, such as philosophy and literature. European knowledge and study of arithmetic, geometry, astronomy and music was limited, mainly to translations of some of the works of ancient Greek masters such as Nicomachus and Euclid. All trade and calculation was made using the clumsy Roman numeral system, and with an abacus based on Greek and Roman models. By the 12th century, though Europe was beginning to trade with the East, and Eastern knowledge gradually began to spread to the West, Robert of Chester translated Al-Kazimi's important book of algebra into Latin in the 12th century, and the complete text of Euclid's Elements was translated in various versions. The great expansion of trade and commerce in general created a growing practical need for mathematics and arithmetic, which entered much more into the lives of common people and was no longer limited to the academic realm. Europe's first great medieval mathematician was the Italian Leonardo of Pisa, better known by his nickname Fibonacci. Although best known for the so-called Fibonacci sequence of numbers, perhaps his most important contribution to European mathematics was his role in spreading the use of Hindu-Arabic numeral system throughout Europe early in the 13th century, which soon made the Roman numeral system obsolete and opened the way for great advances in European mathematics. A mathematician of the 14th century was the Frenchman Nicole Orcam. He used a system of rectangular coordinates centuries before his countryman René Descartes popularized the idea, as well as perhaps the first time-speed distance graph. Also, leading from his research into musicology, he was the first to use fractional exponents and also worked on infinite series, being the first to prove that the harmonic series 1 whole plus 1 half plus 1/3 plus 1/4 plus 1/5 is a divergent infinite. The German scholar Regiomontanus was perhaps the most capable mathematician of the 15th century, his main contribution to mathematics being in the area of trigonometry. He helped separate trigonometry from astronomy, and it was largely through his effort that trigonometry came to be considered an independent branch of mathematics. Mentioned should also be the Nicolaus of Cusa, or Nicolaus Cusanus, a 15th century German philosopher, mathematician, and astronomer, whose ideas influenced lately mathematicians like Gottfried Leibniz and George Cantor. He also held some distinctly non-standard, intuitive ideas about the universe and the Earth's position in it, and about the elliptical orbits to the planets and relative motions, which foreshadows the later discoveries of Copernicus and Kepler. Egyptian mathematics. The early Egyptians settled along the fertile Nile Valley as early as about 6000 BC, and they began to record the patterns of lunar phases and the seasons, both for agricultural and religious reasons. The pharaoh's survivors used measurements based on body parts to measure land and buildings very early in Egyptian history, and a decimal numeric system was developed based on our 10 fingers. The oldest mathematical text from the ancient Egypt discovered so far, though, is the Muscov papyrus, which dates from the Egyptian Middle Kingdom around 2000 to 1800 BC. It's thought that the Egyptians introduced the earliest fully-developed base 10 numeration system, at least as early as 2700 BC, and probably much earlier. Written numbers used a stroke for units, a heel bone symbol for tens, a colored rope for hundreds, and a lotus plant for thousands, as well as other hieroglyphic symbols for higher powers of 10 up to a million. However, there was no concept of place value. The Rhind papyrus, dating from around 1650 BC, is a kind of instruction manual in arithmetic and geometry, and it gives us explicit demonstrations of how multiplication and division was carried out at that time. It also contains evidence of other mathematical knowledge, including unit fractions, composites and prime numbers, arithmetic, geometric, and harmonic means, and how to solve first-order linear equations, as well as arithmetic and geometric series. The Berlin Papyrus, which dates from around 1300 BC, shows that ancient Egyptians could solve second-order algebraic quadratic equations. Multiplication, for example, was achieved by a process of repeated doubling of the number to be multiplied on one side and of one another. These corresponding blocks of counters could then be used